Hi everyone, this is the part 5 of subtopic 3.3 hydrocarbons. I'm going to move on to slide 3. In part 4 video, I didn't get to really cover alkene and alkyne and writing name and structure of it, so we'll cover that. And also there will be a bit of focus on drawing structure from its name. Sorry, the other way around. No, I'm right. Drawing structure of hydrocarbon from its name. So let's look at that. We'll be looking at which slide is it? Systematic nomenclature, slide 29. That's where the alkene starts. So for alkenes, the longest carbon chain must contain the double bond. At the end of the day, this is a carbon chemistry. So carbon to carbon, double and triple bond, they matter. So you have to include double bond or triple bonds into the longest carbon chain. Okay? Even if the branch of carbons may allow you to see it in a way that it's not it is part of the longest carbon chain, you may just have to ignore that and focus on double bond and include that as part of the longest carbon chain. Next dot point, number the position of the double bond, give the lowest number possible. So if you had, say, 5 carbon chain and double bond appears in between the first one and second carbon, if you count from your left, the number 1 is going to be the position of in. However, you could also count from the other way and say that it's 4th carbon. Now 4 is not good. Give 1 as a number of position where in occurs, the double bond occurs. If you have any other branches like methyl for 1 carbon branch or 2 carbon branch ethyl, if you see them, you name it as it is. But you have to follow the order or number that you have given to each carbon that contains double bond. Hopefully that makes sense. So here's an example. You see that just above here. I have done that on the board as well. So here it is. This one here. So you see this in your slide. 1, 2, 3, 4, 5 carbons and double bond is here. Now it's closer to this end, so you have to actually start naming from this end. 1, 2, 3, 4, 5. Where does the double bond occur? It's the second carbon, between second and third. Don't worry about the third carbon. You give 2 as the lowest number and a position of this double bond. So it's going to have 2 in as the ending, or you could do, well, there are 5 carbons, so it's going to be pent. So you can do either pent 2 in as the ending or hyphen to hyphen pentene. So you can put 2 in front of pentene. That's the same as pent 2 in. I personally prefer the top one because pent 2 in directly shows where this double bond occurs, on the second carbon that is. If you see a branch of carbon there, which only contains 1 carbon, so that's a methyl group. Where does it occur? 1, 2, 3, 4th carbon. So 4-methyl is what you need to add. So 4-methyl pent 2 in or 4-methyl hyphen 2 hyphen and then pentene. They are both systematic names, and yeah, they're both fine. All right, back to this, and I've got another example which is for alkynes. It's not part of SACE stage 1 requirement, but I'm just gonna introduce that anyway. If you ever see triple bond ending the suffix of the name of the compound will be yne, Y-N-E that is. And the longest carbon chain must contain that triple bond as well, just like alkene. Alkyne is going to be the same. You have to give the lowest number possible for the position of triple bond, same as alkene. number and name any branches if you have methyl or ethyl group. Here is an example again, and I did that on the board for you. So, oh, by the way, I use skeletal structural model. So I omitted all the hydrogens. You only see ends of the line for where the carbons are. Okay. There are 1, 2, 3, 4, 5, 6 carbons, and as you notice here, I started counting from the right because it's the closest to the triple bond that occurs. 1, 2. So second carbon, triple bond is occurring between 2 and 3, but you ignore the 3, you just give 3 as its name. Hence, I've got 6 carbon, which is hex, hyphen 2, hyphen, and YNE. It's a bit hard to pronounce this one. Hex 2-ine. Yeah, it's a bit of tongue twister for me. Or you could do hyphen 2, hyphen, and then hexine. Hexine. What's attached to the 5th carbon is a methyl group. You just see a line, but there is CH3 attached at the end of this bond. So 5-methyl hex 2-ine or 5-methyl 2-hexine. They are systematic names for this compound. Now practice reading this formula as well, structural formula, but written with only skeleton of it. So that one. All right, so on the next slide, you will have this drawing structural formula from the name that you might be given. What you have to do are all these. So steps. Step 1. Identify the length of the longest carbon chain and draw it first. So if it says pentane, you have to draw 5 carbons and next to each other. And it says ane, so you don't have to worry about adding double bond or triple bond. All of them will be just connected with single bond. Name the carbons on the carbon chain. All right. You just number them. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Either way would be fine. The thing with molecules are, if you have got 3D model like this, if you number it 1 as 1, 2, that will be the same. Even if you flip it around, it's still 1, 2. Then attach any branches or alkyl group. If you have got methyl group, you would have CH3. In this model, I've got OH group. But yeah, you can have ethyl or methyl, 2 or 1 carbon. Add in all hydrogen atoms. If you are not using skeletal structural molecule, a structural model, you'd have to use hydrogen, 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 expand it, or you do it as CH3, CH2, and so on. If you're using skeletal model, you can just omit all the hydrogens. Make sure that number of carbons appear at the end of each line, the bonds. Okay. So there's an example. Draw the structural formula for 2,3-dimethyl pentane. Oh, I shouldn't have left a gap in between methyl and pentane. There shouldn't be any space between two. So 2,3-dimethyl pentane. Have a go from the name. What information can you get? And you are again also expected to know how to draw structures containing more than 1 double bonds. So diene would be the ending for anything that contains more than 1 or 2 or even 3. It would be that with tri, tetra, 4, 4. I don't think you get that high, but yeah, you are expected to be able to draw structural formula in different types. Okay. So that's the ending of this video. I'll see you next one.